So participants, let's start with the next session. Some hands-on on what you have studied today itself from the morning session to the last session. So you have gone through attention and transformer models. So let's have some hands-on on that session, and definitely you will learn or you will get some visualization of what and how those concepts works for BERT and GPT. So over to you, ma'am.
Sure. Thank you, sir. So, welcome back, everybody. So I think first of all, I like to give some quick overview about if you want to uh, train your own model or use existing models. So, with the transformer architectures, there is a really nice repository of all these standard models and datasets which are commonly used for fine tuning, and it is called as Hugging Face. Many of you might already have heard of it, but yeah, I think first let's start by looking at Hugging Face, and then we can go. The way I have scheduled this session is we'll look how to use a GPT model for inferencing. So for all the hands-on exercises, we will be using code snippets or codes from the Hugging Face repository itself. And then for the BERT model, we'll try to fine tune it for the task of classification of review, right? So we will be looking at two tasks. First is we will just do simple inferencing using GPT. So I'm not sure if you have covered various sampling strategies uh, today, but even if you have not seen that, we'll do just simple greedy decoding, and we'll do other kind of decoding also, and you can play with different parameters and try to generate more creative outputs or more deterministic outputs given some inputs using the GPT-2 model. And then with BERT, we will see how we can fine tune it for a specific task. And specifically, we will be looking at the classification of the review types, right? So this is, I think I'll just share this link. And if you do not have an account at this huggingface.co, so I'll request you to create an account on this, because if you want to access any of the models which is given here, we need to have access to this. So I'll tell you how to use this, but in the meantime, let me just share the link for this in the chat window. Probably you can just log in here. Right. So, like I said, so this is Hugging Face page, and you can see here it nicely provides models, data sets, and there is a lot of documentation also which is available here. So for example, right now, if I want to see how I can use GPT-2 model, right? Because as we saw, many of these models are trained on really huge data, right? Like, for example, we were discussing that GPT-2 is trained on 40 GB of data, right? So we can't do pre-training of these models ourselves because we don't have that kind of compute available with us. And on CPU, it would take a lot. It won't be possible to load the model itself, and access to GPUs is usually costly. And the models, more modern models which are coming up these days, they will be at least having 1 billion, 2 billion, 7 billion parameters. Like these are the smaller ones that we will see in these days, right? So that's why, and also usually, like the use case that we, or in general, many people will have is that we want to build a network for a specific task, right? We want to build our model for specific tasks. So it is always good to have access to these pre-trained models. So for example, here, I suppose I just want to look up at GPT-2, how I can use GPT-2, right? So I have just typed here GPT-2, and it is already recommended that. Actually, this is an open community. This Hugging Face is an open community. So if you do fine tuning using some data set on this GPT-2 model, then you can upload that model also to this Hugging Face repo, right? So it's always good to look for the official release of the model whenever you are building your models. So for example, we know that GPT-2 was released by OpenAI, right? So under Hugging Face, they have this OpenAI community handle. So that's why you can see there are other GPT-2 models also coming up, right? So probably this is some user who has trained GPT-2 for Chinese language also. Like it looks like that. They have trained it on Chinese corpus and they have released that model also. So, but for our case, we will look at the official release of the model, like those who initially built it. So this is the GPT-2 model. So here you will nicely find a model card which will give a description of what this model is about. Uh, like it's different because this is updated by different people. So they whatever details they would have updated, you will find it here. So usually, I think the important thing to look for is this how to use section, right? So most of these models will provide a small code snippet or example telling you how you can use this model. So for instance, here in PyTorch, if we want to use this model, what we have to do is, so first of all, even to use this models which are being shared by this Hugging Face repository, right? What we need to do is we need to install this transformers package, right? So if you are familiar with PyTorch, so if you have used PyTorch for building your deep learning models, so there we will usually create an environment, right, in which we will install different dependencies, like we will install PyTorch and CUDA and other things. So to use this model, what we need is we need access to this transformers library. And once we have, or you can also think, even if you're not familiar with PyTorch, it's okay. You can think of it as as just another package or library which is available out there. So first we need to install this transformers library. And here, for example, if we look here, what they are doing is to use this model, what we need to do is we need to just import the tokenizer for GPT-2. And this is the name for that tokenizer, GPT-2 tokenizer. And we can also get the weights of the pre-trained model using GPT-2 model, right? So tokenizer, as you all know, it is responsible for giving you the token IDs, right? Corresponding to different words. So for a given vocabulary, whatever is your input, it will give you corresponding IDs. And then for those IDs, we can look up or the model will internally look up for the embeddings from the embedding metrics. So here first what we are doing is this is true for any transformer model specifically if you are working with that. You will first load the tokenizer and here like you can see the name that you need to give is just GPT-2. If you give this name, it will load the tokenizer corresponding to GPT-2, right? So by default, there is a path, cache path, HF cache path, where it stores this models which you will be downloading, right? So you need not even specify it. It will just download it at some predefined location. And then after that, here they are loading the model. So GPT-2 GPT-2 model from pre-trained. So this is the function that we can use to load our model. So now this contains our tokenizer. This model variable contains our model. And suppose we have an input like this, say text, replace me by any text you'd like. Actually, you can put any text that you want here, like generate a story or write a poem or the weather is nice today. And then probably the model will continue generating tokens after that, right? So what we will do is given some input text like this, we will first encode it using the tokenizer. So this encoded input will contain our token IDs. So in this tokenizer, we will pass text, basically the prompt for which we want to evaluate or do the inference. That is the text that we will pass in the tokenizer. And then this return tensors equals to PT means we want it to return the tensors corresponding to this. And then output would be then how we can get the corresponding output is we can do a model and we can pass a pointer or reference to this encoded input. So basically what will happen is first this text is getting encoded and then we are passing this encoded text to the model and from the model we can get the output. So this output will still be in terms of token IDs here. So they have not shown it here. I have another notebook which I'll share with you. So we need to decode this model output, right? So that will have the output. And further, it can have few other details about the models, like what are its limitations, what is the license, and if there are any restrictions. Since this is an open source model, they have also released details about the training data. So if you want to actually look at what was the training data used to train GPT-2 model, so like I said, they had proposed this web text corpus that they generated by crawling Reddit post. So you can go here and look at it. What are the different domains which were there, right? Which they had used to train the model. So you can find a lot of interesting things here. They will also report some of the evaluation results across different benchmarks that they have obtained, and the paper corresponding to this model, right? So now also you are seeing these buttons here, right? Like train, deploy, and use this model. So I think the most useful one that I find is this use this model, and we want to use it from the transformers library. So if we will click on this, it will just give us a code snippet. So pipeline is another abstraction over this auto tokenizer kind of a thing. So, but it's better, like it's up to you. You can use either this or this. For our use case, because we are just doing an inference, it's okay. We can use any one of these, right? So let's look at it. So I'll just share the link for this notebook. Maybe you can open it at your end and try to use it. So we will be running this code in Google Colab, and I'll tell you what to do. Let me just put this link in the chat. Maybe first you can just see what I am doing, and then I'll give you 10 minutes of time or some time, and you can play with it. And then once everybody is able to run this code, we can proceed with the fine tuning of the BERT model, right? Um, so here it's a very simple PyTorch code. So what we do is first we are importing Torch. After that, from transformers, we are specifically importing this GPT-2 LM head model and GPT-2 tokenizer, right? So one thing is, if you will see here, when I did this use this model thing, right, it was actually, if you will notice, if you want it, it was suggesting some other way to load the model, right? Auto tokenizer and auto model for causal LM. So these are more generic classes. This auto tokenizer and auto model for causal LM are more generic classes, and the one that we are using in our example here are specifically for GPT-2, right? So these are the child classes of those parent classes. So that's why you can see the model name has also become just GPT-2. So this is, so either way is fine. If you want, you can actually try to load it using that, and try to get a working code using that. So here now we are importing the GPT-2 model and the tokenizer. After that, we are writing a class where in the init function, we are initializing the tokenizer, the model, the device. So device basically tells whether you want to run it over a GPU or CPU. So if we want to run this code over GPU, we'll have to keep the device name as CUDA. So here it is just checking this torch.CUDA is available. It checks if CUDA is available. That is, if a GPU is available in the underlying hardware. If it is available, it defaults to CUDA. Otherwise, it defaults to CPU. And then this self.model to self.device, this command, here we are moving this model to the device, right? So initially the model will be loaded on CPU, but after that, if we want to use CUDA, we'll move it to the GPU. And then this text generator class has another function called as generate text. So whenever we are generating these outputs, or whenever we are doing inference using LLM, we have several input parameters that we can set. So prompt actually corresponds to the text for which we want to do the inference, right? So this is because GPT-2 is a language causal LM model. So it will, if we will give it some input string, it will try to complete that. So that is why they have described as input text to continue from. And then max length parameter defines how many, up to how many lengths we should decode. So it will stop, the generation would stop if we end up generating either 100 tokens, or if the model encounters an end of sentence token before, right? So all these models, when they are trained, they use special tokens like begin of sentence or end of sentence to mark where the sentence is starting and ending. So here, when we specify the max length, the stopping criteria for the LLM becomes either if, say, after generating 20 tokens itself, an end of sentence token is generated, so it will stop the generation, or in the worst case, after generating 100 tokens, it will stop generating the output further. And then there is another parameter, temperature parameter. So temperature parameter basically controls how much randomness would be there in the generated output. Basically, if the temperatures, for higher temperatures, your output would be more creative. So, and for lower temperatures, like specifically say if you make the temperature as 0, in that case, you will be generating the greedy output. So at each token, you will be predicting the most probable token, and then you will be, and that way you will continue the generation of the output. And similarly, if you have, I think this top K and top P, if you have gone through this decoding strategies, nucleus sampling, um, or top K sampling, then you can play along with these as well, right? So what, or in short, actually, this is what it does. So if you are setting top K is equals to 50, what it will do is it will tell how many highest probability tokens to consider. So whenever we are generating a token, it will pick the first 50 most probable, not the first one, the 50 most probable tokens. Here, remember that for each output, we get a distribution, right? That's why we use a softmax. So at any time step, whenever we are predicting the next token, so for that token, we output a probability distribution. And this probability distribution would be over the entire vocabulary that we have, right? So for each token in our vocabulary, we will have some probability assigned. And when we do greedy decoding, what we do is we pick the token which has the maximum probability as our output. And that is what we feed as the input for the next time step, or next word to be predicted. But when we are using this top K50, what we are saying is, instead of just choosing that highest probability token, pick the 50 most probable tokens and then redistribute the probability distribution over them. And after that, you do the decoding. Similarly, top P is a better way of doing it. So here, instead of saying like pick top 50 or top 5, here we say that consider all the tokens such that we cover 95% of the probability distribution. So even if you don't understand this fully, it's okay. I think you should read about it later and then just play around with these different parameters. For now, maybe you can just play around with temperature and see that at temperature, if you set the temperature to 0, you will always get the same output, because that will correspond to greedy decoding. Like at each step, when you are making a prediction, you will always choose the token that has the highest probability at that point. So that would be the greedy decoding. But as you will start increasing the temperature, your outputs might become a little less meaningful, or they'll start becoming creative, and after a certain point it might even become a little less meaningful, but you'll see interesting outputs there, right? So going to the code, how we can use it for generation. So first what we will do is So here we are calling our tokenizer to get the token IDs for this input prompt. So inputs, uh, uh, and after that, so this token IDs would be there in this input IDs. And after that, we are getting, so in this code snippet, we are also getting the attention mask. Then we are setting up these different arguments which we want to use, which we are passing it as input to this function: maximum length, maximum temperature, top P, top K values, and things like that. So so there are some default values already set. Maybe you'll just for now you can just play around with temperature parameter. And then with torch.no underscore grad tells it not to use any gradient, because we are just doing inference. So we are not interested in computing the gradients for any of these on any of the model parameters. And finally, this model class has a function called generate. So we use this self.model.generate, and to it we pass this input IDs that we got here, and we pass the attention mask and the generation arguments, and this will give us the output sequence, right? And after this, so this output sequence would contain the IDs, token IDs. So we want to decode it. So we'll do self.tokenizer.decode to get the generated text, right? And this skip special tokens is, so we were seeing those, like I said, this will have begin of sentence, end of sentence, those kind of tokens, right? So if you don't want to see those tokens in the generated output, you can set this skip special tokens to true. If you will set this to false, you will start seeing those tokens also in the output, right? So it is up to you. And finally, we are returning this generated text. And if this gives some error, this is included in a try and an except block. So if this gives some error, we will catch it as an exception and just print that there was an error, right? And after this, what we are doing is we are just initializing this class. So here there is some sample prompt that we have taken, say the scientist discovered. And then we have used different sampling strategies and tried to decode. So these are the, so you can see this something like this happening here, right? So this is GPT-2 model getting downloaded in the Colab. And then you can see different outputs here, right? So these, so this output contains the input also. So the scientist discovered, right? So you can see the output still contains the scientist discovered. And then this is the prediction generated by the model. A new way to get the data from the ground, right? So by you can see that these are not deterministic, because these sampling strategies, top K sampling and nucleus sampling, these are not deterministic. So you'll see some good outputs here. Maybe you can just set the temperature to 0 yourself and then generate the output. You can try to set the skip special tokens to false and see that you are able to see the special tokens in the output. You can try with different inputs, and you can also try varying this K and P to see how it affects the generated output, right? So maybe you can take next 10 minutes to do that. Also just go to this runtime option and click on change runtime, and ensure that you have selected this T4 GPU option, right? Otherwise, your code will not use GPU. It will run on CPU, which would be really slow, and the inference will take a lot of time. So I've shared the link of this Colab, sorry, of this notebook in the chat window. Please make a copy of it before running it. So you can just click on File, and just there is an option here to save a copy in Drive, right? So save a copy in Drive so that you have whatever changes you will be doing, it will be local to your notebook, right? Don't edit this notebook. So maybe you can try this on your own for the next 10 minutes. And after that, we can, and if you are facing some errors or issues, you can post and I can try to help you to run it. Also, another interesting thing could be to use this this way to load the model. and the code snippet that they have provided as it is. You can just use this code snippet that they have provided as it is and try to see what is the output that you are getting if you want. So if you are facing, first of all, if anyone is facing access issues, please paste it in the chat so that we know that uh, uh, you are facing access issues. If not, please go ahead, carry on, or maybe send a thumbs up if you're able to access it. So I hope everybody is able to run it. If you are facing any issues, please feel free to post it in the chat window. So let's wait for another 2-3 minutes so that everybody completes. I think at around 6:50, let's switch to the BERT example, how we can fine tune BERT for a downstream task. Mm. So I think by now everybody should have been able to run it. If you are not, or if you are facing some issues, you can post it in the chat now, or even later also if you will post. We'll see if I'll try to see if the issue can be resolved. I'll try to respond to it. So let's move on to how we can fine tune a BERT model, right? So yeah, one of the reasons we are not, I'm not like in this session at least going into implementing this from scratch is because I think that using this Hugging Face library is much more practical, and that is the way like you would be actually using it to build your own application, right? So, and given the time constraint and that the session is online, I thought that this would be much more effective to learn. But like as a suggestion or as a recommendation, it's always good to try to implement the transformer architecture that you saw in the first half, and try to train it for some small data set. The performance might not be as good, but it will be a good exercise. And at least the basic transformer architecture, implementing it from scratch is good. For all these other architectures, it's good to use whatever is available out there, right? And build on top of that. Okay. Now coming to the BERT model. So like we searched for GPT-2 in the Hugging Face, we can also search for BERT here if we want to use BERT model. And BERT was released by Google. So I know that this Google BERT seems to be the official repository. So here I can see that there is this model called as BERT base uncased, right? And to ensure that this is the same model, we can read through the description that they have provided, right? So another thing is that if I click on this Google BERT itself, right? So you can see that it is now listing all the different BERT models which are there. So usually what happens is, because this is an open source library, this Hugging Face library on its own. So here we can see that there are 15 different variants of this model which are available, right? Along with the date and time along with the dates when these models were last updated. So it seems that this was last updated in February 2024. Um, so you can use any one of these models based on your use case. So for example, you can see there is this BERT base German cased, right? So BERT base is, we saw that there are two kind of models, BERT base and BERT large, depending on the model size. So the BERT base indicates whether this is the base model, or you also have this version BERT large, or this is the large model. And this cased and uncased, the difference is that for the cased models, the uh, case, whether it is in uppercase or lowercase, right, in the input, that also matters, right? So sometimes we have things like acronyms, right? And the acronyms are usually written in all caps. So there, the having this information about the case is also important. So these cased models are sensitive to that case information, and this uncased model, you can assume that they have applied this pre-processing where they are changing the case of all the input to lowercase, and then hence they are insensitive to the case of the input sentence, right? Whether it is uppercase or lowercase. So we will use one of these models here now. So first of all, here what we are doing is, in the first block here, we are installing the dependencies. Like I said, for using the models from this Hugging Face, actually Google Colab by default has this library installed. So this was not required to be done explicitly. And that's why you will see that when we tried to use this GPT-2 model, we did not get any error that transformers library, even during the import itself. If the transformers library was not there, we would have received an error that transformers not found. But because in Google Colab environment, it is installed by default, we did not get such error. But if you are working on some system locally, you first need to install this transformers library. And then for loading these datasets, Hugging Face provides another library called as datasets library. Then there is another Python library called as evaluate, which has different functions like compute recall, compute precision, F1. So this evaluate library provides various metrics that we can use to evaluate the quality of the generated responses, right, for a particular task. And accelerate is a library which uh, provides optimizations that helps to run the code faster, right? So you can just install this. So here I have already installed all of these dependencies. So you can see it is installing various packages and dependencies which are required to run this. And since running this code, I was getting some errors. So I did this pip install -u datasets. So basically what this would do is it would ensure that I have installed the most recent version of datasets library, right? So then I did that. And then here is the fine tuning code. So I'm right now giving a walkthrough, and then I'll tell you some settings that you need to do. So here, then first we are logging into this Hugging Face hub. So there are some models for which we need access, specific access to this. To even use those models, we need to have some specific access. So to show that that also, here we are logging in using our Hugging Face credentials, right? So from Hugging Face underscore hub import login, and we are logging in here. So what when you will do this, you will get a window which will ask you to enter your Hugging Face ID and token. So I've asked you to create a login into this, right? So I have already logged in using my personal ID here. So I just entered that email ID, and if it asks for a token or an access token, you can go to in the Hugging Face page, you can go to you can click here on the right hand side, and you'll get various options. Here you will see an option called as access tokens, right? Once you will click on this, you can create a new token, and on creating a new token, it will ask a name. So say I'm giving it some dummy name, and then it will ask various permissions. You can leave it to the default and just go ahead and create this token, right? So once you will create a token, you can see a token on your screen. Just copy it and save it, because once I close this, I will not be able to see this entire token again, right? So you can just copy and save this token. And then you need to specify this token. You need to add this token to your Google Colab, right? It should know that, okay, this is the token that you want to use. First of all, in this login, after login, you can paste that token. So let me just run this again. So here it is asking for the token. So I have already copied, and this is ideally you should not do. You should save it locally somewhere where others can't access it. But I trust you all are good. So I'm just keeping it here. So just do a login, and still if you get some then you need to go here, this key option that you are seeing in the Google Colab. You can uh, so this is the environment variable, right? In our local systems, like, we have different environment variables. So in Google Colab, this is where we can set these environment variables. So there is an environment variable called as HF underscore token that we need to set, because basically this then tells us that, okay, whatever activity we are doing, it is associated with this Hugging Face account. Use this Hugging Face token for that, right? This takes care of various permissions. So just enter the name HF underscore token here. Maybe I can add, just click add new secret, and you can enter HF underscore token, and the token that you had just copied, you can paste that token here and toggle this thing to true, right? So since this already exists, I'm getting an error here, but you will be doing it for the first time. So you can do that. So once you do that, you should not be getting any errors related to accessing Hugging Face. Okay. So this was some initial setup that you need to do with Google Colab and Hugging Face. So post this, what we are doing here is, so the dataset that we are using is called as Yelp reviews dataset. So Yelp is a website where people review different restaurants, services, and products. So we are loading that dataset. So this dataset is provided with Hugging Face itself. So for loading this dataset, we are importing from the datasets library of Hugging Face. We can import load dataset function. And then from transformers, we are loading this auto tokenizer class. And this is how you can load the dataset. It is as simple as that, because this is an inbuilt dataset. You can just give load dataset, and this is the name of the dataset, Yelp review full. And likewise, we can load the tokenizer of. So here we are using Google BERT base uncased model, right? So we are loading its tokenizer. And then uh, so for this tokenizer, they wanted to use some parameters, like here padding is equal to max length. That means, so the padding parameter defines how much padding we want to do, right? So whenever we'll have some batch of sequences, suppose I have a batch of 32, right? So I'll have 32 sequences, and all these sequences will be of variable length. right? Some sequences may have some sequences is a sequence is basically in some input sentences, right? So some sequences might be say of length for 40 tokens, others might be 100 tokens, something like that, right? So so what we do is we pad the rest of the tokens. So because we want to construct a tensor, right? Or we our input will be a tensor. So what we want to do uh, is we want to have the same length. That is a necessity that the length should be the same. So if a sentence is shorter, containing say only 40 tokens, for the remaining 60 tokens, we will append a special token called as pad token, right? So every model defines some pad token. So when we are saying padding is equals to max length, so it will ensure up to the maximum length that you have specified. Uh, like up to the maximum length in the given batch. So in a given batch, if 500 is the maximum length, so it will pad all the other examples up to 500 tokens. And then truncation equal to true. So if there are any sentences which are greater than that, they will be truncated. Then dataset equals to dataset.map tokenized batched equal to true. So here it will just load like the data set will be loaded, and it will be batched with this instruction, right? And then here what we are doing, instead of training on the full set, because that will take a lot of time, we are training on just 1000 samples. So that's what these two lines are doing. We are sampling just first 1000 samples after shuffling, right? So randomly it will sample 1000 training examples and 1000 validation examples. And after that, Hugging Face provides a trainer class. Maybe we can just open it once, right? Yeah. So this is a trainer class that Hugging Face provides. So it is a really nice abstraction for training models, right? You just need to specify simple parameters here, like what kind of model you want to use, what is the data set over which you want to do the training, what will be the batch size, then what is the learning rate. So just those high level hyper parameters which you have while training any deep learning model. So those will be your training arguments. So for instance, you can see here. So to use this, we just need to specify the training arguments, like what will be the output directory where our model will be stored, where the after fine tuning, we'll get some model checkpoint, right? So where the checkpoint would be stored, what is the learning rate that we want to use, what is the batch size we want to use for training and validation, how many epochs do we want to train our model for, right? Weight decay is another parameter related to optimization. So do we want to use weight decay or not? Then there is this eval strategy. So eval strategy can be either epoch or stepwise or step. So if we are choosing epoch, that means after we have run the training for certain number of epochs, then only we want to do the evaluation, right? Validate how is the performance of the model. And if we are doing validation after epochs, completing several epochs, then we will also like to save it after epochs, right? We can also do it in between epochs, say just after running 500 steps or something like that. So that also we can, for that we need to specify it as step. And then, do we want to load the best model after training? So the best model would be chosen based on this validation number, right? So the model that achieved the best validation performance, that would be chosen as the best model. And this push to hub is, I was showing that we can also push our trained models to Hugging Face Hugging Face repository, right, or library. So if we set it to true, it will push it to Hugging Face under our name, our username. But if we set it to false, it will not push it. It will just store it locally, right? And once we set this training arguments, we can just pass these training arguments and call trainer.train function, and it will do the training, right? So it is as simple as that if we use this trainer library, right? So that's what we will be doing here. So we have loaded this data set, and after this, now because we want to classify the input reviews, so from transformers we are loading like we are importing this auto model for sequence classification. And here we have specified that number of labels is 5, right? So this Yelp reviews will have 5 classes as the target, as the potential targets. Right, so it is loading the model. So while it is loading the model, let's go through. It is done. It is a small model, so it is done. So now here we have, if you remember in the beginning, we also installed this evaluate library. So here we are just loading, here we are just defining the metric that we want to use to evaluate the or validate the quality of the generated output. So because this is a classification task, we can use accuracy. And here we have just defined the metric for that, right? So basically for the predictions, we are trying to predict which particular class, given the logits, which particular logit has the highest probability value, and that would be the predicted class. And then after this, like we saw in the example given on the Hugging Face trainer library description, we are just setting the training arguments. So we are setting the output directory as Yelp review classifier. So this is where our checkpoints would be saved. So it would create the directory here only in the Google Colab. And the evaluation strategy that we are using is epoch, and we do not want to push this model to the hub, right? So these are our training arguments. And once we have this training arguments, we can create a trainer object where we are specifying that where we are specifying the model which we want to train, right? So in our case, if you see here, we have already initialized this model, and this model is auto model for sequence classification, which is initialized with BERT's pre-training weights, right? BERT's pre-trained weight, BERT model's pre-trained weights. And then these are the different training arguments that we wanted to pass. And our training data set is in this train split of the data set, right? And eval is in, so here although we could have also passed this small data set, right? Small train or small eval, but we are passing the entire training data right now. And the metric that we want to use, we just specified it here, that this is the function that should be used for computing the accuracy. And after initializing this, we are just calling trainer.train. So it's giving an error, trainer is not defined. No? Just let me see, maybe some import is missing. Yeah, it's not able to identify this trainer function. Just a second. Did we not import it? Yeah, so it's missing this statement. We need to do this. Just let me do this. And it will now start the training. So we need to So this is using WandB. WandB is another application that is really good for tracking different runs of the training that we have. So you can also just log in here. So as you can see now, the training has started. So we should have this is the reason we should have, this is a really big data set. So right now it says that it will take approximately 49 hours to train this, right? So maybe we should rerun this with a small training data set, right? That we had extracted here. Small train and small eval. Let me just do that because we can't wait for this long, right? So let's just stop this run, interrupt it, and do it for small underscore train and small underscore val or test, small underscore eval, right? So it says it is not defined. Let me see. Okay, this is not, you can just do it here. Let's just do this. Okay, now it is much faster. It will just get trained in 5 minutes. But obviously, since we are using much lesser data to train this, um, the accuracy will not be that great, but that's okay. You can ignore this TensorFlow part. This one shows how we can use. Also, Hugging Face is compatible with both PyTorch and TensorFlow. These are two different frameworks which are usually used to train deep learning models, right? They take care of a lot of these things like how to use GPU and efficiently for training purposes. So these frameworks internally take care of that. And also these provide us standard libraries for building, like it will have CNN layers, um, transformer model, like we are able to load this Hugging Face library and use it out of the box, right? So usually both are good, TensorFlow and PyTorch, but these days PyTorch is much more popular than TensorFlow. So that is what is used for training. So maybe by the time this is getting trained, you can try to run it on your own as well. Anyways, this is shared with you. So I hope that you found this interesting, or at least you will now you know where to go and start if you want to build your own model. Yeah, so there's a question like any good PyTorch learning resources, YouTube doc, ma'am. Uh, so see LLMs, they are by definition, like the full form of LLM is large language model. So they do not work for images. There is another set of models called multimodal models. So they are either called VLMs or MLLMs. So VLMs are vision language models, right? So you can look for that. So one of the popular vision language model is Lava. Even that these VLMs are available on Hugging Face. So you can look for that, or it might be available as a separate GitHub repository. So you can use that for images if you want to work with image data. And also for PyTorch learning resources, yes, there is a nice YouTube series actually. Very small series. You can finish it in a day. It's just, I think, a few hours, 2 to 3 hours, not longer than that. So probably I can share the link. I'll look it up and share the link. I have it with me. So that could be a good starting point. Any other questions? Thanks, Pradeep. Thanks for asking. So see, currently after one epoch, it has now printed, this is the loss value. So the loss is 1.05 after first epoch and the accuracy is 54%, right? Let's see how this improves after one more epoch is trained. So since we have not specified how many epochs to run the training for, it will be using some default value for the number of epochs. So right now it is running the validation. So you can see that the model is learning and the learning is slightly slow. So the accuracy improved from 54% to 55.8%, right? So we are, I think we are sort of out of time, sir. So this is it. So this was the tutorial I had. And so this notebook is shared with you. Again, please copy this, make our own local copy, play with it. You can read more about different functions, different arguments that can be passed to this in this Hugging Face repository, right? Here itself, you can see different arguments, what different functions are available and what are these different functions doing. There will be some code snippets about how you can customize this code. So Hugging Face is a really nice resource if you want to learn. Oh, this needs access. Yeah, let me just ensure that it is shared with everybody. Sorry. Yeah, please check now. Yeah, so yeah, that's it. So any other questions? Yeah, I'll share it with Vikas sir and along with the materials, Pradeep, these notebooks and my slides, and then you'll have access to that. Over to you, Vikas sir.
Okay, thank you, ma'am. This was such a wonderful session. Actually, the way they have interacted throughout the coding is, is exactly what we were expecting from this session. So thank you so much for this interactful session. And I hope all the participants have enjoyed the session. They have some exposure to BERT and GPT architectures and how they are basically being built. Apart from that, I also hope, means we also hope that you might have some good idea about different repository that you might use for your for building a pre-trained models. Okay, means you can use those pre-trained models. You don't have to build it from the scratch and use according to your requirement. So definitely this session will be very much helpful for all the participants that have joined this session. So thank you so much, ma'am, for your time. Uh, we are literally very much privileged to have you here. Thank you so much, ma'am.
Thank you, everyone. Thank you, sir, for giving me this opportunity. So I'll maybe after the session, I'll send you the details over mail, and people are asking for the YouTube playlist for PyTorch. So I'll share some good resources, and maybe you can forward it to the students also.
Sure, ma'am. Thank you so much, ma'am.
Okay, yeah. Thank you.
Okay. So participants, we are done for the day. We will be meeting tomorrow at the same time, 10 a.m. Tomorrow we have a session on diffusion model, definitely one of the trending topic nowadays. So the session will be taken by Dr. Satyendra Singh Chauhan. I hope to see you tomorrow at the same time, 10 a.m. Okay, thank you all. Thank you, Dr. Surendra sir, answer. Thank you, Asutosh. Okay,
Okay, sir. Okay, sir.